Argolight produces QC solutions for fluorescence-based microscope. We are doing also hardware reference material and software that are able to analyze this hardware. And the topic of this session is to show you how to do more quality control in less time. So I will talk briefly about the hardware reference materials that we produce and the role of the fluorescent patterns that are embedded into this reference material. I will show you fast how to analyze this pattern thanks to our software, and I will show you the latest features that we have developed in April and that will help you to earn even more time. And in addition, I will show you what can you do with all this measurement. I mean, how to store all this data that you have been analyzed. So just some words about Argolight. Our headquarters are situated in Bordeaux, in south of France. So we also have our production and software development into the headquarters. The company has been created in 2012, and we are quite 12 employees. We are a young team, very sporty, and we work at 80% at the international, thanks to a lot of distributors. And our vision, our goal is to stay the best, so to have the best solution for QA/QC solution for fluorescence-based microscope, fluorescence-based systems, I should say. So quality control is often seen as a burden. When I meet people, when I meet microscopists into imaging facility, some often say that QC is time consuming. It is considered as secondary. They often have several tools, different from different manufacturers, for assessing their microscope performance. Those tools don't last long, just some months or some little years. These tools imply to have some knowledge in script creation if you want to have something a little bit robust, and therefore it is not fun. So in addition, quality control is often seen as something laborious. And what I would like to show you is that our QC solution will make you like QC. So I will first of all show you how we can help you to earn more time in your QC session. So thanks to some users and which I have discussed with our solution, they can do in 1 or 2 hours what they used to do before in 1 day. By this gainer time, I will show you that you will have less downtime from your microscope. So you will be able to make this microscope more usable, more available. I will try to show you also that you can perform QC more easily, because thanks to our solution, there is no preparation, there is no timeout, and you can do everything in just some click. So no manipulation, no preparation, just some click. You will also gain more confidence into your system and into your process, especially because one of the main error in quality control process is a human error, because 2 operators don't do the same thing the same way. Thanks to more automation, more software, and with everything embedded into one single slide, you have less human factor. So I will show you how you can gain more confidence into your protocol. In sum up, I would say that our solution presents the best ratio, time of use, and data collected. By data collected, I mean in quantity and in quality. So the best ratio of this market for this topic. About our solution, so if you have understood, the process is very simple. You have to capture images of the patterns that are embedded into our reference material. Then you have to analyze these images. and you can track microscope drift into a timeline on another part of our software. And at the end, you can share reports for this user or for internal purpose. I will just get nigh to see if there is no question on the raised hand. Okay. So the process, capturing images. So about our patterns, what we do is that we lithograph this pattern into a piece of glass that is patented and that we create in our headquarters. So these patterns can be in 2D and 3D. We manage their shape, their size, and their position. They are excitable from 300 nanometers to a little bit more than 650 nanometers. After it depends on the sensitivity of the sensor of the camera. And they are non-photo bleaching, so it means that you cannot bleach it, but you can create a short-term decay of the intensity. The non-photo bleaching aspect is a very strong key point of the solution. So these patterns are embedded into our reference materials that can be slides or plates or whatever. And then once you have captured the image of the patterns, you can send it to our software. I will show you in live how it works. And these patterns will be analyzed and we will be able to take some measurement of the drift of the bias that you have into your fluorescence-based system. With all the measurements that you have done, that you have performed, we will send it to another part of the software that is called Daybook 3 Data Manager, and you will be able to see all this data on a timeline. And as you can see visually, you can see if on a specific criteria you are well under your tolerance, or if something is going to be out of your tolerance and create some downtimes or everything else. At the end of the process, you can create some reports and that you will be able to share with external user in order to justify that your microscope fleet is performing well or not. I will just show you a video because I don't have any microscope, so I will show you this video. I hope it is working fine. It just lasts less than 2 minutes. It will just present the process for how to acquire the patterns. So I hope this video will replace my lack of microscope. But you see how it works. There is just little key points at the beginning to find the patterns, and when you have the pattern, everything will be very fast. And I will try to show you how. Just another point before showing you how it works. This is the different kind of metrology criteria that we are able to assess with our more hologram slides. So we will be able to send tens of criteria within the field uniformity, field distortion, lateral co-registration accuracy. We will propose two different approaches from resolution, the line spread function and the lateral resolution that are based on different patterns. We have also two different approaches of the stage drift. Stage motion control is like repeatability of the stage, and the stage drift during this stack, I think you understand what it is. We also have the intensity response and the spectral response. And what I will try to show you in live is the power and irradiance in real time, in time lapse, and versus power instruction. You will understand. I will show you how it works thanks to some user cases. So we will do like if we are a microscopist into an imaging platform, and a user come to us to tell us there is a problem, and I will show you how you can diagnostic the problem of the user thanks to our solution, in order to, first of all, to have something that justifies that your microscope is going well or not, to be able to help you to know the truth on the performance of your microscope, and in order to be reactive to the inquiry of this user. So first of all, he has a new microscope that he don't know. He don't know which power instruction correspond to which power in milliwatts. He just knows that above 2 milliwatts, he risks to glitch his sample. So you just know that your microscope, you can just make 10% or 80% of power instruction, but you don't know what it represents in milliwatts. So you will use a power meter in order to make this measurement. So I suppose that you all have a power meter, but what is interesting thanks to this device is that you have also the power meter and the fluorescent pattern on the same device. So you have all the measurements in just one time. So I will try to show you in live. So first of all, you have to launch the software. So the software, as I told you, is divided into modules. There is data analysis and data manager. So we will launch daybook analysis. I will show you my installation. If you see my this image on my phone, I have a cycling lamp that is eliminating our Argo power. I think I am at the lowest level, and now I will try to launch. Okay, he's already there. So Argo power is the name of the mole hologram device. It is based on the pattern that you can find on the Argo HM. I will show you at the end the portfolio of product. So at this beginning of the screen, I will choose the power meter. It is just the step before all the other analysis. In order to run the power meter, need to be connected to my computer by USB. So it is very, very simple. I will choose the channel. We will do like if it is a GFP1, and that's all. So I can run my power measurements. So at the lower, no, I don't think it is the lower intensity. Yeah, maybe. Okay, so at the lower intensity, I am at, so in the case of these users that don't know how many milliwatts he have to put into his microscope, at the lower intensity of my lamp, I am at 20%. So in terms of power instruction, I will say to Daybook that for 20% of my microscope, he can consider this measurement, 2 milliwatts, 0.25 as 20% of my of my of the power of my microscope. Then on the second step, yeah, it is inverted. So you can see on the timeline the different measurements that are performed. I should have begun by that. You can also create a time lapse if you want to see if there is a decay after some minutes or some hour. It is the case for my lamp, for example. After some minutes, there is some fluctuation. So now on the second level of my power instruction, like if it were a microscope, I am at 60%. So I wait that it is stable, and I will add the measurement. And at the maximum, I am at 100%. I will, like before, I will wait that it is stable. I think it is. I will add the value. And now I can see on the lower part of the screen on this graph what is the linear regression between all the measurements that I have done. So first of all, I have a power measurement on my power instruction. So I can go back to the user and tell him what are the different measurements that the different power of the light source of the microscope. And secondly, if you are into your QC process, you can see that the instructions are not linear because there is apparently something that go out of the tolerance. So now I can go back to the user, and he tell me now that the microscope that he is using is not as sensitive as the last time he used it. So now you have another issue to diagnose. So two questions: is the microscope really declining in terms of intensity, or is it the sample that has an issue? So thanks to the different patterns that we embed on our slide, the ones that are suited the best for that is intensity gradation. So in all the images that you will have acquired of the reference material, you will select the one that suits the best. So first of all, you have to select the analysis that interests you the most. So I go in intensity response. It will remind me what is the pattern that I need to analyze to have those to make this test performing. So I will choose the 4x4 intensity. In fact, we have two patterns for intensity. The 4x4 is pretty well. So I will run the measurement, and I have my my analyze. So at the left of the screen, I can see the image that has been analyzed. On the middle of the screen, you can see the linear regression of all the measurements and the error bar around all the measurements. And the two main parameters that you can look at are the Pearson correlation coefficient that is of 1. So the closer it is of 1, the best it is. More precisely, it is 9986, so quite 1. So the linear regression of the system is perfect. It is a good point. And the second point that you can analyze is the pattern dynamic range. It means that the brighter pattern is 6.48 times brighter than the darkest. So just like that, it is difficult to know if your system is at the top of its performance. But for all the measurements, the best is always to compare your data to the previous analysis that you have performed. So it seems pretty good. So you can go back to this user and tell him, okay, the system is performing well. Maybe your sample have a problem. But in a microscope, there is a lot of elements, and what will help you is to diagnose which part of the or which path of the microscope has an issue. So depending of the issue or the measurement that you perform, you can be able to discriminate some elements into the path and to advance in your diagnostic. And as this user come back another time to you to tell you that his images seems blurry, you will be able to take another measurement of another pattern. So if it seems blurry, it means that there is a problem in the resolution of the microscope. So you will take one. I told you that we have different approach of resolution. In this way, we'll choose the lateral resolution test. And the lateral resolution test is based on 4 patterns that are the same, but with different orientation. These patterns is I would say that it is composed of pair of lines that are gradually spaced. So in each pair of line, you have 50 nanometers of space in addition each time. So you will go back to Daybook analysis. You will select the lateral resolution, and you will choose the pattern that suit for this test. So the horizontal gradually spaced line. What I didn't told you before is that for quite all these tests, we have this tag of each pattern. So if the lateral resolution pattern seems blurry, it is just because it is one images into this tag. So I will choose one, whatever the one it is, and I will click on the best focus selection. And it is the only thing I have to do because all the other parameters into a test are supplied by the metadata that you can find in all the images. So I am voluntarily fast on this term because when you know the software, you have an information in less than 30 seconds. So the pattern is already analyzed. You can see on the graph that some peak and some valley has been detected. So there, the valley is not very clear, and the valley is more clear for each time. And for a criteria contrast of 26.5%, I get this measurement of my lateral resolution. If it is not enough clear in all the tests, you have the data that are separated by primary metrics, secondary metrics, etc. So in the primary metrics, there is a reminder of the criteria contrast that we have chosen, 26.5. And for this criteria of contrast, I have a lateral resolution of 445 nanometers. So it is not the best of what we can expect of a wide field microscope because all this data comes from a Zeiss Axioimager M2. It is the one that we use at Argolight. So it is a real microscope with real drift. So 442 nanometer of resolution. And if I have chosen a criteria contrast of 0, the resolution would have been of 300 nanometers. And I also have some indication about the signal to noise ratio. That seems pretty good. So we can go back to this user and tell him, okay, the resolution, we will do like if the resolution were not good at all. And there, thanks to the previous test that we have performed and this one, we can circumscribe the problem to this element of the microscope. So the different issues that we could have considered could come from the objective, the pinhole, the dick slider, measuring mount, or an intensity-rated issue. So all the patterns that are embedded on the slide and all the 9 or 10 tests that you can perform with the most polyvalent slide will help you to circumscribe all the problems that you can have on a microscope. Just a reminder of what we have saw in less than 1 minute, where we will be able to have one truth on the microscope performance. So I have been voluntarily fast in order to show you how it can be, but I will come back on the software and explain you some information. But I'm pretty sure that some of you will ask me, can you make it even faster? And I would answer, yes, we can do even faster than when you have saw. And it is thanks to the new updates that we have added in April that are called batch analysis and file watcher features. It looks like that. It is a window that will, for the moment, you will be able to analyze 3 patterns that will perform 5 metrological tests. And in the future, we will be able to perform all the tests in the same time. I will show you what it is. So first of all, I have my list. I have my images. I will clear all this list. So batch analysis, just a reminder. Take the example of microscope responsible that have 5 or 10 microscopes that have to acquire the images of these 10 microscopes very fast and to analyze it in the same time in order to make gain of time for him. What he will be able to do is to take all the images on each microscope and each time to send all the images that has been acquired on a shared folder where is, I forgot a step. I have to activate the file watcher. So file watcher will monitor the arrival of new images into the source folder. So I have my source folder there. And each time new images are arriving on this folder, they will be automatically added into the book analysis. So I have 10 or 11 QC session. It can be 11 microscope, and each time you put the new data into one system. So it is what I will do. So I have my measurements there. I will take all these measurements that I have performed, put it into the monitored folder, and nothing happened into the demonstration. Yes, it works. So while you are acquiring the images on a second microscope, the images of the first are uploading into the software. It makes you the possibility to gain 5 or 10 minutes for each microscope, because if you have this stack of 16 patterns, it is a big gain of time. So I have all my images, but now I want it to be analyzed fast. I will select the batch analysis. It is a window that you could see in the PowerPoint. First of all, the window will ask me for each system do I want this batch analysis. It is for my microscope. I only have one, and in each system you can have different configuration. I mean, one objective plus one filter plus one cube, etc. So I have only one profile. I will select the acquisition channels that I want to perform and the reference channel that is necessary. Then I will choose the patterns that I want to be analyzed into these images. So I have images of the field of ring. I have images of the 4x4 intensity, but I don't have any images of the 3D crossing stair. Now the software will try to find the pattern, the good pattern, thanks to the keyword that are embedded in the name of the image that you have performed. So it is important to have a good name in your images. I know that the real name of the pattern is field of rings, and my colleague called it matrix of rings. So I will just search for the name rings. It is the same with the 4x4 intensity. My colleague called it 16 niv. So it is not the best word, but it will help me to find it. So I will just type 16 niv, and that's all. As I only selected these two patterns, I will be able to perform only these 4 tests: field uniformity, field distortion, and lateral co-illustration accuracy that are based on the field of ring, and the 4x4 intensity that is based on 4x4 intensity. Then the last step is to tell to the system how many tests he has to perform in the same time. So if you make just one test, it is quite to do it manually. And if you have a powerful computer, you can perform, I don't know, 10 tests in the same time. As I am on laptop, I only do 3 or 4 tests in the same time. So I will run the test. At the left of the screen, batch analysis tells me what he is currently doing, and at the right of the screen, it tells me what has been performed. You can see a sum up on the right of the screen. I have asked him to perform 5 analyses. He have succeeded to make 5 association with one test and one pattern, so it is good. And there is 0 error. So the research of keywords have well performed, and all the tests are good. Now I am sending this test to Daybook Data Manager. It is the part of the software where you manage your system, your profile, and you store your data on a timeline, etc. So now I will show you. So a sum up of my different microscope. I only have one with one acquisition profile. And there is my timeline with all my data. So in DAPI, I only have 2 measurements, two QC session with 3 tests that has been performed. But the best timeline I have is the GFP. So what you can see there in vertical is all the QC sessions that I have been performed on this system and this profile. I have all my different tests that are here under these buttons. So field uniformity, field distortion, etc. It is only the test that I have performed, and I have not performed all the tests. And you have a sum up of the different information below the timeline. So for the first test, you have the heat map that is reminded here, the intensity profile there, and the primary metrics there. So the first May last year, the centering accuracy of my system was about 73%, and the field uniformity, the other criteria that I like to look at, 87%. 87%. And what is interesting in this set is that you can scroll different dates in order to see how the heat map is moving, and it will give you some information on how the drifts are moving in your system. And if it is not sufficient for you, you can add new cards in order to have a focus on a specific criteria. So for example, for the centering accuracy, if I want to know how the centering accuracy was during the quite last year, I can see that the average is around 74%. It was most half of the time into my tolerances, but I have some strange data at different steps of the year. It is the same for the field uniformity. You can choose the criteria that you want to track with error bar, spread, or an average. And if it is not sufficient for you in terms of information, you can also track another information by adding a new card thanks to line chart, table, or images, and you can select the test that you want to see. For a line chart, for example, with an intensity mean, I can add a new card and track it. And you have all these features for all the tests. So for example, for I saw a question for the lateral co-registration accuracy. I think we can have some images. There is just a moment to load all the data. And it is also the opportunity to talk you about the thresholds, because if you don't do a lot of QC, maybe you don't have any idea of the threshold that are necessary. We can suggest some thresholds for confocal microscope or wide field microscope, and the criteria that are interesting to monitor. For example, for the Pearson correlation that we talk about, you can make some different thresholds, and you can customize it, change it, and save the changes and save a new template of data. So the data manager, we already saw it. It is a timeline when you can monitor your drift and see if something is becoming annoying and out of your tolerances. So to sum up, our hardware reference material are designed to last a very long time. The first prototype that we have created more than 10 years ago don't show any sign of decay. So we can expect a lifetime superior of 10 years for our reference material, and it is due to the patterns that are embedded into the glass that we have created and patented. The association to the software is very simple to use. So the software is not mandatory, but it is a very big gain of time. You could see that the results are very quick to obtain. I make some tests this week. In less than 1 minute, you have the information that will be helpful for you to take a decision. Solutions are all in one. I mean by that that when you buy a slide, you also have the analysis software that is included. Without the batch analysis, because it is a premium feature. But what I did manually in the previous slide, perform in less than 1 minute. So with each slide, you have the analysis software, warranty for the presence and fluorescence of the pattern, support for any technical or question, and you can have between 9 and 10 tests into one single slide. For the Argo Power HM that I show you on the cam, you have 10 tests possible, and it is just for the moment. We will develop also another test in the future. So this is the product portfolio that we can propose for standard solution. It is also possible to make custom solution if you have specific needs. So there is the Argo Power that I show you. That is based on the pattern that we have into the Argo Power HM. So HM means high magnification. So Argo Power and Argo HM are designed for system from 20x of magnification to 100x of magnification. I should also told you that all the slides are compatible to lots of media. Like glycerin, oil, and water, but water for a short time. Then you have the Argocin that is suited for super resolution microscope that embeds a lot of other patterns dedicated to special deconvolution algorithm. And you have the Argo LM for low magnification system. We also propose some patterns in plate format with Argo WP, dedicated to HCS systems. And we have more affordable slide in the series Argo Check that are dedicated to homogeneity, resolution, or intensity. So as I told you, everything comes with the analysis part of the software. The commercial plan is called Daybook 3 Troubleshooting, in opposition of Daybook 3 Quality Control, that is the premium offer where you have everything. In terms of pricing, our solution, the most all-ground solution is Argo Power. It is proposed at 7,000 euros, a little bit less than 7,000 euros. The other all-ground solution, Argo HM, SIM, LM, are proposed at 6,000 euros. The Argo WP is a specific solution, so it needs a lot of service in order to develop some script. It is a special project. And the Argo Check series have not exactly the same balance, so it is more affordable, but there is a difference between homogeneity and the two others. And in this price, we have the Daybook troubleshooting, in other words, the Daybook analysis that is included, the lifetime warranty on the slide, and all the features that you can have in Daybook analysis. The other part of the software, so quality control, that embed the batch analysis, the file watcher, and all Daybook data manager, is proposed at 40 euros by month by microscope. In addition, so I remind that the warranty on the presence and fluorescence of the patterns is a warranty at life. So in 10 years, if you have an issue with the intensity of your patterns, it will be under the warranty under normal condition of use, of course. You have also the support for question and technical issues, in addition of the documentation that will be updated. Everything is updated, so if you are missing some key elements in data in batch analysis, for example, the lateral resolution that is not yet in batch analysis, it will come in the future thanks to the updates. And we don't talk too much about the additional services that we can propose, but if one day you have a doubt about your slide performance, we can make performance assessments, quite like the certificates that I showed you on the cam. We can also make a calibration of the Argo Power, and we can help you to make some database migration, especially if you are currently user of Daybook 2 and you want to pass to Daybook 3. We will help you to migrate your database. So we have several services around our product, and you can ask if you have any question. So thank you very much. Have a nice day. I will send you the presentation in some days. The same for the video. Thank you very much, and have a nice day. Goodbye.